Good morning, everyone. We welcome you for session 1 of day 4 ACT ATAL online FDP on Internet of Things for Smart Grid. Today, the speaker is Dr. K.C. Suresh, Associate Professor, Department of CSE, Sri Sairam Institute of Technology, Chennai. And the topic we are going to discuss today is Smart Grid Data Analytics and Sensor in Smart Grid. About Dr. K.C. Suresh. He has completed his BE in Computer Science and Engineering in Saraswati Velu College of Engineering and did his ME Computer Science and Engineering in Crescent Engineering College and did his PhD in Computer Science and Engineering under Anna University. His strengths are he has analyzed, processed, and visualized complex data sets using analytic tools, statistical modeling, machine learning, data mining using R, and have good experience on linear regression, KNN, SVM, neural networks, decision tree, random forest, AdaBoost, and certified EMC academic associate in data science and big data analytics. He has also patent he has also a patent and has several publications in his research area. The area of interest of Dr. K.C. Suresh are machine learning, data analytics, computer networks, and mobile computing. We welcome you all for this session and we thank Dr. K.C. Suresh for accepting our invitation and handling this session. With no further delay, I hand over the session to Dr. K.C. Suresh. Thank you, sir. Thank you for accepting our invitation. You can take over the session, sir. Sir? Suresh, sir? Sir, your audio is muted, sir.
Okay, I'm sorry. Very good morning to one and all. Okay, good morning. So today we are going to explain. We are going to discuss about the very detail on IoT analytics. So in the last 3 session, 3 days, what you have discussed is what you have understand is what is IoT and what are the sensors we have to use for IoT and what are the kind of service provider we have to use for connecting all kind of sensor and what are all the motherboard, which means that I'm talking about Arduino or Raspberry Pi. What are the things we have to use for connecting IoT device? Everything you have studied in the last 3 sessions, but today what I'm going to give you is basically I'm from computer science people, so I would like to give the analytics on IoT. So the IoT is actually a simple kind of thing we can able to build or we can make the product. Whereas when you try to build a new kind of product, based on that we can able to analyze as well as give the major insight on it. So that is what I am going to give the detailed view on IoT analytics. So today our session objective is to understand what is IoT analytics. So part of IoT, the analytics is nothing but it's basically derived from artificial. So I think many people have heard about that artificial intelligence and machine learning is one of the leading kind of technology nowadays. Why? Because the world that are generating data per day, terabytes of data are generating. So if you take any kind of device or any kind of system, what we are using the current scenario, every system is generating a huge volume of data. So the data is data is very important for us to understand what is in future is going to be happen. Hi guys, there is a network issue, so that's the problem. So we'll problem here. Okay, fine. There is a network issue, that's why that is not audible, I think. So we'll start the presentation right. So, as I said that every device in the real world scenario that are generating the huge kind of data per day. So, if you consider about the Walmart, in the Walmart itself, they are generating around terabytes of data per day. So, there are the large amount of transaction will be performing in that particular organization. If you consider like a Walmart in the real world scenario, we have the lot of supermarket or kind of banking sector, every kind of activity that are generating the data. Data is very important for it nowadays, because based on the data we can perform some kind of insight, so that we can understand what will be happen the near future. For example, if we consider in the last 10 years what we are having in the Walmart history is, if you are getting the sales revenue of per day, annual sales revenue, average annual sales revenue will be around 1 crore if you consider. So the what will be the next 10th year? What will generate the amount for the from the Walmart supermarket? So that will be performed by some kind of machine learning algorithm. So why don't we apply this kind of machine learning algorithm in the IoT device, so that we can get the new kind of additional information we can make it. So that is what the objective of machine learning and AI in the IoT analytics. So I'll start the presentation right now. So I am giving the idea what is AI and what is machine learning and what is IoT. That is what I am trying to say. So IoT, you know that the Internet of Things, there are the large number of objects that have been connected with the Internet. So we generally simply called as Internet of Things. So in the, if you consider this is the Internet of Things, in the behind the code behind of the process, we have the number of layers, which means that the processing layer. In that processing layer, the sensor will generate the data. The generated data will be stored in somewhere in the database. So if you consider the data will be stored in the database, that particular data we can able to perform a different kind of machine learning algorithm, so that we can be able to get the predicted result. For example, I'll give you an idea how IoT and IoT analytics works. So if you think that in our organization or in the factory, we are laying around 100 sensor around the campus, on the 150 acres of campus, we are laying the around 100 sensor over in the campus, all are connected with the internet. The internet, this is what generally called as Internet of Things. This scenario is also considered as an Internet of Things. So the sensor will generate the data per second. They will be generated sensitivity data. For example, if you are laying the sensor, temperature sensor or air monitoring, air pollution sensor, the sensor will send the information that generate the data and send it to the corresponding code behind, which is nothing but the centralized unit. Maybe a cloud, or maybe a server, or maybe a Raspberry Pi, whatever you think, that the collected data will be stored in somewhere in the common computing center. That computing center, we are going to, that is what the information what we are getting it. So we can understand based on the 100 sensor, we can understand that the average temperature of that particular organization or average pollutions of that particular organization will be considered by adding all the sensor value divided by n, we'll get the average value of temperature or air pollution or whatever the kind of information you expect from the sensor, we could be able to perform it. So the computational center or the computing device, server, that is the major part of IoT analytics. We cannot perform the IoT analytics in that particular sensor. Sensor or Internet of Things will collect the data. The collected data will be stored in somewhere in the centralized processing unit. Where in the centralized processing unit, we can able to apply the machine learning and AI technique, so that we can get the useful insight. So if you are not performing the AI or machine learning approach in that particular computation device, we can able to perform only the statistical analysis, the average temperature of the campus or average air pollution of the campus, that will be calculated without the help of AI and machine learning. But if you would like to know about the future thing, for example, if for example I would like to predict the tomorrow's weather or next year weather, we can able to perform by use of machine learning algorithm based on the data what we are getting from the sensor. that will be stored in the processing unit. We are going to embed, or we are going to apply the machine learning AI technique that produce the result that will help us to understand what will be the next or what will be the future solutions or future temperature of the campus. So this is what the scenario I would like to explain. I think you people understand the IoT analytics is not going to apply in the sensor or IoT or Internet of Things everything. So all the data will be collected and stored in somewhere in the centralized processing unit where they are going to apply AI and machine learning techniques. So I would like to give elaborate explanation about machine learning in AI, how it works in the AI. So before that, I will give the presentation about what is AI and once again. Sorry guys, I didn't show the PPT yet. I'll present right now. So what I have explained is so far what is AI and what is machine learning and what is IoT. So the big data and is a major base for AI and analytics. AI is artificial intelligence. The data analytics is actually a machine learning algorithm that cannot work alone. Actually, that AI and machine learning techniques can be applied for data. The data is generally called as structured or unstructured data, which is stored in the kind of centralized processing unit, what I said earlier. So if you consider there are a lot of under sensor over in the scenario, all the sensor information will be stored in the processing unit. That data, if you consider, which is very limited or very little, we generally call as data. If you consider we are producing the large amount of data per sensor, then we consider as big data. So there is no difference between data and big data. If you consider data size is too large, then we generally call it as big data. So why using the term big data means we cannot apply the AI and machine learning technique for the normal data. That is not actually giving the useful insight. If you have the large amount of data, then only we can able to learn the machine so that it predicts the near future. For example, I have the two values. The age, for example, I'm going to predict the weight of the person. So I have the history. I have only 4% history. The first person having the age called 1 year, the weight is 14. The second person having the age called 10, the weight is 20. Third person is 20, age 20, and weight is 30. Fourth person, age is 30 and weight is 50. This is what the data I have. This is generally called as data. This is not actually a big data. If I'm going to predict the data of, predict the weight of the age 25. 25 age அப்படின்னு கொடுத்தீங்கன்னா definitely it has to predict. But it generally seems that the age between 20 to 30, the average value of the weight will be the 45 kg. So that is what the prediction accuracy. So we cannot say that exact accuracy will be getting from this four data. If you consider, if you have the around 1 lakh records of data, various kind of formation, various kind of attribute, so that we can able to predict the exact result of the particular prediction. So that is what we generally call as the data is not useful for applying the machine learning AI technique. When you think about the data size is large, definitely the prediction accuracy will be getting high. The prediction accuracy will be getting high. So that is what we are using the big data. So usually you think, I think you people know that your sensor will generate per second around KBs of data per sensor. If you consider the large sensor has been laid out in the particular environment, the data getting the high. If you consider the data as collected for past 10 years, the data will be coming to the terabytes of data. So the big data is the major focus for analyzing, applying the AI and machine learning. So IoT is a part because IoT is also a major contributor for generating the big data. I think you people know that the data will be generated in various forms. For example, banking domain. If you are transaction, if you are trying to withdraw the money, deposit the money, that will be generated as data. If you want to do purchase something product in the supermarket, that transaction information also called as data. So everything, the real world scenario, what are the data we are trying to use and store the information, that will be called as data. IoT is also a kind of a data generator. IoT is also a data generator. So general part, the big data, the AI and machine learning or AI and data analytics that will be applied, we can apply the big data concept. So that this is a new area where we can apply the machine learning concept to the IoT technology. So in the slide, you can understand first data explosion. Data explosion in the sense, the real world scenario that data are created. For example, various sources of data. That's what they're trying to search. POS is a point of sale. ERP, enterprise solution, the CRM, customer relation and module, email, Twitter, Facebook, Google search, ERP. Everything we generally consider as data. So it's a part. IoT is also a part of generating the data. So in this particular data explosion, there are the large amount of people involved by use of internet, by use of device, by use of POS device, by use of laptop, by use of kind of EVM machines. Everything we generally call as the device that the person we are using that particular device. So the data is generated by these kind of devices. So in that particular thing, the connected devices is generally we think about it, the collective information will be getting high. So IoT, where we can apply the IoTs. IoT, I think in the last 3 sessions, 3 days, we have getting the large information about IoT area. So I just want to skip it because smart factory, we can apply the IoT, connected marketing, innovation, reduce the time to market, connected gaming, micro payment, smart grid, connected supply chain, network style, physical cyber security, business process outsourcing. These are the major area we can able to IoT. Of which the agriculture is also the major. I didn't mention that particular slide. Agriculture is also a major role player in the IoT applications. So that's to be noted. So I'm coming to the core concept, how the data analytics or AI is going to apply in the IoT analytical solution. This is the basic architecture. In that particular architecture, you could understand where we can apply the AI and machine learning concept for the big data. In the initial class itself, I have told you that every IoT device that are generating terabytes of data every day. So the data are stored in somewhere in the database or data stored in a cloud or whatever the platform we are trying to save, because the data are stored. If you consider per day we are generating the terabytes of data, if you collectively we consider about the 1 year's data what we collect from the sensor, the data volume becomes very high. So that data is generally called as big data. So that big data we are going to apply the IoT analytics. So in this particular architecture, you could understand there are the different layers. So here the bottom layer is generally talk about the IoT device, things, device, sensor, everything we generally call as IoT integral part. In the everything we generally call as integral part of IoT. IoT there may be a things or there may be a device, there may be a sensor. All the things we generally call as edge. Edge that things are objects that are connected with the internet, then we generally call as internet of things. So the second platform we generally called as the data stored or data computation engine. The edge computing is an advanced concept. Basically, clients, it's not a problem. So all the sensor or device or things are connected with the edge computer, a computational engine. The computation engine may be a wired connection or wireless connection, local area or wide area, whatever the kind of connectivity may be there. The sensor may be in the local area or in the wide area, maybe in the abroad or whatever the distance you can able to keep. So, but with the help of, if you consider the local area, we could able to connect with the Wi-Fi or WLAN or common LAN, wide LAN, whatever the concept you can able to connect. So the computing device are generally connect with the edge so that all the information will be come to the computation engine. So you just understand this is the in IoT part where the IoT will be coming to the computation device where the computation engine we have to getting about the analytics as well as the data store. So after getting that particular computation engine, the computation engine that collects the data that is called as data injections. Data injections. Data injections means we generally collecting the unwanted data also. For example, in the sensor, it's also generate the timestamp. It's also generates about the basic coordination where that sensor is laid off. There are a lot of attributes will be generated by the sensor there where we can able to get only the useful information to be stored in the database. The unwanted data will don't help us to get the insight of the sensor analytics. So if you want to analyze something, for example, if you want to predict the weather of the car, weather of the campus, from the sensor we are just collecting the various kind of information. For example, coordination. Coordination is an important point for wind direction or temperature or temperature and timestamp or data, college sector. So maybe there will be a lot of kind of attribute will be generated by the sensor that all the data which will won't help us to analyze or predict the new kind of insights, which means that if you want to predict the future weather, I mean tomorrow's weather, for that we don't want unwanted message, unwanted attribute like data, date, timestamp. That won't help us to predict the future. Maybe the wind direction and temperature will be the most impacting factor to predict the near future prediction weather. So the unwanted data will be removed from that particular analysis. That's what data injections. So after that, we are just going to generalize the data analysis. So this is what the basically generally called as analytics or AI. Analytics or AI. So in that particular data analysis, what you are going to do is there will be a kind of machine learning algorithm. There are a lot of machine learning algorithms like time series, time series analysis or weather prediction. Is the most helpful algorithm to predict the time series. I think many people you would have heard about that stock market prediction. Based on the time and date, we could able to predict the stock value of the particular organization. If you consider today the TCS share value is around 100 rupees, tomorrow what will be the value of share value of the TCS, that we can able to predict by use of time series analysis. Like that, if you consider this is the timestamp, date and time is a very important factor. Date and time, if you consider today's date and time, we are predicting the near future weather of the particular organization. And the area, what will be the temperature and what will be the moisture, everything will predict the use of the time series analysis. So that is generally called as data analysis. This is what the major part are artificial intelligence part in the IoT architecture. So this is the generally called as application and people process. The application is nothing but every IoT product that has to be interact by kind of interface or kind of objects. You definitely need any object or interface to interact with that particular interact. For example, if you have the safe home, it's a kind of automated IoT automated system. If you want to control your fan from your remote area, that is possible by help of by kind of process and a GUI. Without a GUI, you cannot able to control your device. So that is generally called as people process. The person who is going to interact with a particular age, the people who is going to interact with this particular things. This is called as people process. We generally design the UI for interacting this particular age. So I have told you that earlier. a data analysis, data injection is generally integral part of IoT analytics. So big data, in earlier slide itself I have told you that data generation process is called as big data. If you are generating the large amount of data, we generally call it as big data. So that's what data injection we generally call. In this layer we can able to perform. So the data analysis is the machine learning or AI part, where we can perform the analysis and analytics over the big data. So if you consider in the automobile process, I think the many application IoT can be performed in many application area, of which automobile industry is the large kind of sector that can be able to adapt IoT things. So where if you consider we don't have any data analysis and application, this is what a general scenario of IoT engine. Whatever you are trying to build a IoT, so we generally call as this IoT engine. So where in the earlier slide I have told you that there exists nothing but the things. So in the things, edge computing will be stored, data will be stored. The data the people can able to control and monitor, but they don't understand about the data, what it is trying to say. These two layers is generally called as IT layer, where application, data analysis, and data injection. These three things will be giving the useful insight from the data analytics. So this is another use case where we could be able to see where IoT can be applied. So I don't want to explain much about this IoT process, because the session of it is how the analytics is going to apply in the IoT scenario. So these are the port IoT. Port IoT, you could be able to. This is what the shifting center, where there are the lot of things were connected with the Internet of Things. So here the lorry or transport vehicle that has been connected with the RFID or something kind of thing. One second. Sorry for the disturbance. One second, please. ரெடியா இருக்கு சார். லிங்க் ஃபீட் பண்ண இப்ப இங்க வரும்போது. So this is an example scenario of port analytics. So where the lot of objects were connected with the Internet of Things. So every device we can able to give the insight. For example, if you consider the vehicle which consisting the database, which means that the sensor has been layered up with the the lorry or transport vehicle, where we could able to give the route suggestion. if you want to shift from Chennai to Bangalore, there will be a lot of toll and there will be a lot of road traffic that are also to be considered in the transportation. So where the auto route suggestion is a kind of analytics or machine learning engine that able to give the recommendation to the transport driver that he can able to transport the things very easily. So auto route suggestion is a kind of activity that is performed by the machine learning and AI integral part. So next thing is automation of hub operation. Automation of hub operation is which means that the data, I mean, where the ship has been collected the various products from the ship that will be stored in the different uh, warehouse of particular port. So where will be the allotted things will be there, and where the things are not allotted, everything will be collected by use of sensor. If you consider this is the storage area of goods, what we are getting the goods from the ship, all the stored information, I mean, all the products what we collected from the ship that will be allotted from kind of area. So the sensor will have the automated information about the moving and in-moving objects of that particular area. So the automation of the hub operation is completely simplified. When you are having the goods, where the allotted cell will be there, where the unallotted cell will be there, everything will be collected by use of the automated sensors. So this is a kind of internet. So you just consider AI suggestion the space allocation. AI suggests the space allocation. So we have the goods from the ship. So we have to allocate the space for that particular goods. So that will be getting from the centralized recommendation engine. So this is kind of internet of things where this that simplify the work of the humans. So the smart city, this is also one of kind of IoT analytics where we can apply, because every smart city that has been integrated with the large kind of sensor and Internet of Things. So that is what the major plan of the Indian government to lay up the smart city in the India. So when you are consider the cities are becoming the IoT enabled cities, where we can able to apply the IoT analytics so that we could able to get the where the lights are on, where the lights are off, the unused area, everything will be monitored by use of IoT analytics. For example, where there will be a motion sensor in the IoT part, so the motion sensor is automatically detect whether the person is not there or not. If the person is not there, immediately the corresponding things or corresponding object will be on or off. That will be happened by kind of machine learning approach. So everything I have given the detailed picture what we have discussed about IoT analytics. So now what I'm going to do is this all things I have explained. Uh, this slide is enough for you. I'll share you the another slide. Okay, guys. Now I'll show you the Walmart. I think you people know that Walmart is the very big supermarket in the world. So where they are applying the large IoT kind of device in this particular handling the things, which means that there will be a lot of product that is stored in the warehouse. That storing the product in the warehouse is a very tedious task for the Walmart. So that they have laid off a lot of IoT devices in that particular warehouse system. So in that warehouse system, they have applied a kind of big data analytics, so that that helps Walmart to improve their product handling capacity in the warehouse. So this video will help us to understand how the Walmart using the big data and IoT kind of technology in that particular warehouse. So just listen it.
As a retailer like Walmart, we now have a fantastic opportunity with all of the IoT capable devices to collect rich amounts of data that tells us not about conditions in our stores, our merchandise, but also about the patterns and habits of our customers. And that gives us a great opportunity to put the customer right at the center of what we do and use these enabling technologies to provide the business models that our company needs to be successful in the future.
In today's highly competitive marketplace, grocery retailers strive to create a seamless shopping experience that drives sales and builds loyalty with their customers. IoT-connected devices such as beacons, video cameras, digital signage, and smart shelves provide access to huge amounts of new.
So in this video itself, how to understand that there are a lot of IoT devices will be layered up with the Walmart warehouse or Walmart supermarket. All the data as captured as a big data. So that is what they are trying to talk about.
Data on customer activity and present more opportunities for sophisticated insights and immersive customer engagement. IoT data is used to track the effectiveness.
So the real-time data analytics is actually an integral part of IoT analytics. The real-time data analytics, which means that what the customer will expect in the supermarket. If you consider about the Walmart, there are a lot of customers will arrive for that particular Walmart supermarket. So the IoT device, combination of IoT device and the big data analytics that helps Walmart to improve their sales revenue. Why? Because if you consider there is no sales in that particular. For example, they are purchasing around 1 ton of tomato per day for that particular supermarket. The sales is very less. So the customer is not satisfied. There may be a lot of influencing factor not selling that particular product very well. So that will be considered by use of IoT and big data analytics that tell the Walmart manager about the not selling that particular product, so that they may reduce the purchasing quantity or they may remove from that sales item that particular supermarket area.
Of store layouts, exposure to promotions, product interactions, and use of digital kiosks and mobile apps. This data is analyzed in real time to create deep insights into customer preferences and path to purchase. Digital assistance allows customers to find the items on their list, interest them in new products, and select promotions to save money. And for marketers, identifying customer desire, delivering curated content to upsell and cross-sell, and measuring the success of promotions has never been simpler and more accurate. IoT provides service-level metrics and enables store managers to eliminate long queues.
So in this particular slide, you could able to understand that the major part of IoT and data analytics is giving the insight of the particular Walmart or whatever you think about the supermarket. So the total customer count that will be generated by use of two parts. That's an integral total customer count. That may be a kind of sensor that captures the number of customers arriving that particular supermarket, or else the number of transactions which occurs in that particular sales report. You just understand there will be a two part. The first part is counting the person who is entering that particular supermarket, or you consider how many transactions have been made in that particular supermarket. Maybe, for example, in that particular supermarket, they are entering around 1,000 people per day, but the total transaction will be around only 500. So 500 people is not purchasing any item in the supermarket. Just they are visiting and they are seeing and go back from the supermarket. So this is what the two integral ones. The first part is going to tell about the IoT, which means that the sensor which is going to capture the person's count, but we are going to tally with the database, which is not the analytical engine. So that is what customer total count, queue customer length, average waiting time, transaction time, everything will be considered by use of sensors as well as the combination of data. Sorry.
Schedule staff efficiently through cognitive intelligence and make sure customer expectations are being met at every service point in the store. IoT, revolutionizing the retail experience.
So I'm going to give you one more example, then we'll move to this slide. So this is for the play ball, football. Should understand in this football we are laying some kind of sensor in that particular football where that is going to having the angle information and what angle the ball is going through. So everything the data will be collected. From that data we are going to predict which angle will be best for getting the goal or something. That's what the insight what we are getting. So in this simple scenario, you should understand what is the IoT analytics. Just listen to this video.
Good morning, Mark. I talked to Jarvis using this app I built. It uses artificial intelligence to understand me and figure out what to do. Fresh shirt, fire in the hole. Hell yeah.
So the technology like IoT, big data, cloud, and AI ML will play a critical role in creating a solution in the future. So IoT, big data, and cloud. Cloud is actually a storage and processing area. You don't bother about this because that is a computational and processing unit. Where the IoT and big data, it's a combination of IoT and big data is the a major role player for getting useful information. So the combination of IoT, big data, cloud, and AI and ML, everything we generally it's going to be a fantastic future in near future.
As a takeaway, I'd probably just caution everyone to understand that perhaps you should use big data to make your small decisions. Use your gut to make the big decisions.
So I think I don't have much time to explain in detail, which means that I'm giving the abstract content of IoT analytics in your view. But the thing is, the IoT analytics, we can able to having the scenario, we can able to demonstrate. If possible, I'll come to the next session with the demonstration IoT analytics. So before starting this particular slide, this is actually what it is. I mean. This particular thing, Internet of Things offering, which means that IoT, what's an IoT? This is actually a platform which is developed by the IBM. What's an IoT? So many data analytics platform is there in the real world scenario. Google Analytics, which means that Data Studio, Microsoft Power BI, Tableau. These are the major vendor or competitor development platform for data analytics. So, but specifically, they don't have designed for kind of scenarios. But IBM, they have designed for what's on IoT, for specifically for analytic, having the analytics with the IoT things. So this slide is going to explain about how the what's on IoT is work. So what's on IoT is nothing but a basic platform for analyzing the data of IoT. IoT, when you are collecting the IoT data, there is a platform to analyze and give the useful information, analytics in the computational engine. That's what what's on IoT. Before getting starting this particular topic, I would get the feedback from you. Do you have any doubt or once again, do you have any doubt? Just post your query in the chat box. Please post your queries or any doubt. I need your feedback. If you have any doubt, is just post your queries in the chat box. Okay, I think you people don't have any doubt on it, so I'll proceed it. So, as I said that earlier, IoT Watson IoT is the base platform for analytics of IoT things developed by IBM. So, when you talk about this Watson IoT, why we need IoT data analytics platform for IoT? So there are a lot of advanced technique for current scenario, which is nothing but cognitive analytics, cloud computing, POC connectivity, product lifecycle management, embedded sensor. When you talk about the IoT will come under the embedded sensor. This is generally called as IoT things. So these are the advanced topic where the world is going to be changed in near future. If you're using all these five concepts, the world will be getting the technologically that will be changed in near future. So the accelerating advanced technologies, cognitive analytics, cloud computing, POC connectivity, product lifecycle management, and embedded sensor. So this will all these five things will help for business people that improve the sales revenue. For example, boosting the operational performance and lower costing, driving engagement and customer experience, creating a new product and business models, advancing environmental leadership. Everything will be done by use of these five technology. So the world is going to be changed with the help of this five technology. in the following way: boosting operational performance and lowering costing, driving engagement and customer experience, creating new product and business model, advancing environmental leadership. So with IoT, companies are becoming more competitive with a new way to drive better business engagement. So in what it means, there are a lot of questions will be arising for a business people. How much energy cost I can reduce it. For example, I'm using any kind of machinery in my own factory. My question will be always to be reducing the energy of the machine. For example, the machine has consuming around one unit per hour. So how far I can able to reduce the current or power of that particular machine. So that will be my question. So based on the different domain, there are a lot of questions will be arising how to optimizing the performance of a particular machinery or work or whatever the thing you think about it. So for example, if you take another question, I need to risk for developing the complex device. The product developing company, they are deriving the questions of how to reduce the risk developing this complex device. So there are a lot of questions will be there. All the question will be giving the one solution. That is what IoT analytics. That is what IoT analytics. Once again. So these are the major companies they are using the Watson IoT. So IBM developed a platform. They are using large of clients. They are using it. So of which the major is Whirlpool, Delta, Daimler, Verizon, Panasonic, Cone, Siemens. Everything they are using the IoT Watson platform. For these major companies, they are using the large amount of IoT components in that particular development. Whatever the car manufacturing company, AC manufacturing company, elevator manufacturing company, every company they are using to involve the large amount of IoT component in that particular product. So when they are using it, they are trying to extract the useful information from the sensor data with the help of the Watson IoT. So with IoT, I think I have given the large of idea about it. What's an IoT solution? So vehicle, facility, home, health, transport, factory, all the devices are connected. The connected data will be analyzed, and the connected device data will be collected, and the collected data will be analyzed and giving the useful information to what's an IoT solution. That's what they are trying to talk about in the architecture. This similar architecture where we discussed in the earlier slide. So main thing, this what's on IoT, they are trying to connecting the large amount of sensor or IoT devices, and they having the separate information management model where the information can be stored in a secure way. There will be an analytical engine that analytical will help us to give the useful information on the predictive visualization. And finally, we have the risk management also in the IoT Watson platform. So these are the main component. I have told you that there will be a 4 component in the IoT Watson platform. One is analytical, and the second one is the connection management. Third one is the risk management, and finally information management. So in that particular information management, the storage and archive will be handled, where the metadata management and the reporting, query management, everything will be done in the information management system. So where the proactive production, which means that if any unauthorized entries are arising in that particular platform or particular developing environment, the risk management technique will be handled that particular vulnerable or intrusion detection techniques. So there will be a content thing, the content which is nothing but the basic HTTP mechanism where the cloud server will be connected with the help of IoT platform. Next thing is the analytical, the analytics engine that help us to predict the future things or real-time scenarios and conceptual view. Everything will be done in the analytics engine. So all the this 4 model which is developed by the IoT Watson platform, that will be connected with the blockchain. The blockchain is a basic security principle behind with the Watson platform. Blockchain is a separate kind of a technique that will that we have to explore elaborately. So this is not our context, so that I just keep it. So blockchain principle where we have to give the security for particular Watson IoT platform. So we could able to analyze a large amount of data in the Watson IoT platform. So it's a kind of technique where weather data is also help us to identify this particular thing. So in this Watson platform, we have video, image analytics, and audio analytics, machine learning, text analytics, and natural processing. Everything will be integral part of Watson IoT analytics. So I think I just want to conclude that today we will come to the end of the session. The main purpose of this session is to understand about what is IoT and what is IoT analytics. I think I have given the brief introduction about IoT analytics. In the real part, if you consider, there are a lot of technical concepts behind it. So definitely we should understand about the basic things of machine learning and AI. Then only we can able to integrate IoT as well as the analytics in the component core. So that is actually first we should understand about what is machine learning and AI very clearly. Then only we can able to understand the complete structure of IoT analytics. So there are a lot of vendor and the competitor to providing the IoT analytics solution in the real world scenario. There is a huge market capital in this particular segment because they are not touching about IoT analytics in this segment. big data analytics is a separate entity. They are working on about transaction data. The IoT is a separate domain. They are trying to develop a new kind of product for home and factories. But there is no, I mean, there is lot of gap between IoT data as well as the analytical engine. So when you are trying to talk about this combination of two things, definitely the real world market will be huge. So if anybody want to do the IoT analytics, you can go through it about what is analytics as well as IoT. Definitely we can make a good product on it. Thank you. I would like to conclude this session. Thank you. If you have any doubt, you can post your queries in the chat box. If you have any doubt, just post your queries in the chat box.
Participants, if you have any doubt, you can unmute yourself and ask for clarification.
I'm waiting for your valuable feedback as well as your questions. I can able to clear your views. So if you have any doubt, you just post your queries in the chat box. Okay, thank you all. I just wind up the session. Thank you for giving the great opportunity for giving this great lecture to you all. Thank you for listening it. Thank you.
Thank you, sir. Thank you for delivering a wonderful lecture, sir. Thank you for your time. Thank you, sir.
Thank you.
The next session will be around 11:30. I will put the feedback form in the chat box and it will be open for another 1 hour. Thank you, participants, for your patience and listening.